What if the only way to slow down time is to move faster? Not faster in the way you're thinking, not a sprint, not a race. Faster in a way that changes what you are, relative to everything around you. Think about every story you've seen where someone moves at impossible speed. They run so fast the world around them freezes. They step through walls like the walls were never there. They vanish from one moment and reappear in another, earlier, later, somewhere else, entirely. We call it fiction. We call it a power. But underneath the spectacle, there's a question worth taking seriously. What is actually happening, physically, when something moves that fast? Here's one way to think about it. Everything you touch is made of matter, and matter exists in different states: solid, liquid, gas, plasma. What separates these states isn't just what they're made of, it's how their particles move, how tightly they're bound, how much space and energy sits between them. A solid resists you because its particles are locked into a rhythm you can't match. But speed changes rhythm. Push something fast enough, and it stops interacting with a material the way it normally would. It starts moving through the gaps, around the resistance, syncing with the medium instead of colliding with it. Now stretch that idea further. What if time itself works something like this? What if a person moving fast enough doesn't just move through space faster? They begin to move through time differently, falling out of sync with the moment everyone else is standing in, and into sync with another one. Not magic, not a leap. A shift in rhythm, the same way a fast enough object stops feeling like it's colliding with a solid and starts feeling like it's passing through one. It sounds like something built for a screenplay, but this is where the story stops being fiction. Because physics has already been telling us something remarkably close to this for over 100 years. In 1905, Einstein published the theory of special relativity, and one of its strangest conclusions was this: time is not the same for everyone. It doesn't tick at a universal rate. It bends depending on how fast you're moving. The faster you travel, the slower time passes for you, compared to someone standing still. This isn't a hypothesis waiting to be tested. It's one of the most confirmed effects in all of physics. There's a famous thought experiment that makes this concrete: the twin paradox. Imagine two twins. One stays on Earth. The other boards a spacecraft and travels near the speed of light to a distant star and back. When the traveling twin returns, they haven't aged the same amount as the one who stayed behind. Less time has passed for them. Not because their body worked differently, because time itself moved differently for someone traveling that fast. This effect is called time dilation, and it isn't confined to thought experiments. It happens right now in devices you use every day. GPS satellites orbit Earth at thousands of kilometers per hour, and at that speed, their onboard clocks tick at a very slightly different rate than clocks on the ground. It's a tiny difference, a matter of nanoseconds. But if engineers didn't correct for it constantly, GPS positioning would drift off by kilometers within a single day. The system in your phone works because time dilation is real, measured, and accounted for. And there's an even more extreme example, one that doesn't involve a spacecraft at all. It involves a particle you've probably never heard of. It's called a muon, and it's created when cosmic rays slam into Earth's atmosphere. Muons decay almost instantly. They shouldn't survive long enough to reach the ground, but they do, in huge numbers, because they're moving at close to the speed of light. From our perspective, their internal clock runs so slowly that their brief lifespan stretches out just long enough for them to reach us. They are, in a very real sense, living inside a slower version of time, earned entirely through speed. So here's where the idea comes full circle. What began as a question about speedsters phasing through walls turns out to brush against something physics has quietly confirmed for over a century. Speed and time are not separate things. They are linked. Move fast enough, and the rate at which you experience time is no longer fixed. It bends around your motion, the same way a fast-moving particle bends around the resistance of the material in front of it. You are not moving through time at some universal shared speed. Right now, in this exact moment, your rate through time is being shaped, however slightly, by your own motion through space. A person on a plane, a satellite in orbit, a muon falling through the sky. None of them are experiencing time exactly the way you are. So the question isn't really whether you could speed up enough to shift when you exist. The question is, are you already doing it, in a way too small to notice, drifting through time at a slightly different rate than everyone around you right now, without ever realizing it?